Apache Kafka is a highly popular distributed event streaming platform designed to handle real-time data feeds. It is widely used for building robust data pipelines, streaming applications, and messaging systems. Kafka excels at high throughput and fault-tolerant data streaming. For more tech interview materials, please visit our website, bowsy8.com. Core components include 1. Topics. Kafka organizes messages into topics, which are the primary unit for categorizing and managing data streams. For example, a topic named user activity might store all user interactions on a website. 2. Partitions. Topics are divided into partitions for scalability. Each partition is an append-only log where messages are stored in order. Partitioning allows Kafka to distribute data across brokers, enabling horizontal scaling. 3. Brokers. Kafka brokers are the servers that store data and manage message delivery. A Kafka cluster typically consists of multiple brokers. 4. Producers. Producers are clients that publish data to Kafka topics. They decide which topic and partition to write data to, often using a partitioning key to ensure related messages go to the same partition. 5. Consumers. Consumers subscribe to topics and process messages. Kafka's consumer groups allow multiple consumers to share the workload by consuming from different partitions. 6. Zookeeper or K-Raft. Zookeeper was traditionally used for managing metadata and coordination tasks like partition leader election. Kafka is transitioning to K-Raft, a built-in mechanism for metadata management. 7. Replication. Each partition has a leader and replicas for fault tolerance. If a leader fails, a replica takes over, ensuring no data loss. How Kafka works under the hood. 1. Message ingestion. Producers send records, messages to Kafka. Each record contains a key, value, and metadata. Kafka appends these records to the appropriate partition of a topic. 2. Partition leadership. A leader partition on a broker handles all read-write requests, while replicas act as backups. 3. Data storage. Kafka stores messages persistently on disk and retains them for a configurable retention period. This durability allows consumers to process messages even if they are delayed. 4. Message consumption. Consumers fetch messages from Kafka by polling. Each consumer tracks its own offset, the position in the log from which it reads. 5. Replication and fault tolerance. Data is replicated across brokers, ensuring availability during failures. Kafka ensures consistency by electing a leader for each partition and syncing replicas. 6. Scalability. Kafka partitions enable parallelism by allowing multiple producers and consumers to operate simultaneously. Adding more brokers improves throughput. Example use cases are event logging and analytics. Companies use Kafka to capture website click streams for real-time analytics. Microservices communication. Kafka acts as a message broker, enabling asynchronous communication between microservices. ETL pipelines. Kafka is commonly used to extract, transform, and load large datasets across systems. IoT data streaming. Kafka ingests sensor data from IoT devices for monitoring and processing. Database change capture, CDC. Kafka captures changes in databases and propagates them to other systems for synchronization. Advantages include 1. High throughput. Kafka can handle millions of messages per second with low latency. 2. Durability. Data is stored on disk and replicated across brokers for reliability. 3. Scalability. Kafka can scale horizontally by adding brokers and partitions. 4. Versatility. It supports both real-time streaming and batch processing. 5. Fault tolerance. Partition replication ensures data availability during failures. Disadvantages include 1. Operational complexity requires expertise to configure and monitor at scale. 2. Ordering guarantees. Kafka guarantees order only within individual partitions, not across them. 3. High resource usage. Brokers and Zookeeper require significant computational and storage resources. Thanks for watching. For more tech interview materials, please visit bowsy8.com.